With code number 15, 3 sum. This is medium question. Let's get into it. Given an array nums of n integers, there are element a, b, z in nums such that a plus b plus c equals 0. Find all unique triplet in the array which give the sum of 0. Okay, let's check note. The solution set must not contain duplicate triplet. I think we needed to get rid of this edge case. Let's check with example 1. Given array nums is minus 1, 0, 1, 2, minus 1, 4. In this case, sum is 0 is minus 1, 0, 1. So this is the value. Another is minus 1, this one with this one. So minus 2. How we can solve it? Maybe we can start with a Blooper solution. At that time, maybe we can use loop in, loop in, loop. So iterate start from here, and then next iteration here, and then next is to make sum. So then maybe we can find this one. But this one is too slow, so we need to make better way. There are two more solution. First is we able to use two-pointer technique, and then another is we able to use the two set. So in this case, if we use two set, time complexity is n square, and space complexity also n square. The better solution is two-pointer technique. Time complexity, even time complexity is same as a set, but space complexity we can reduce it with the linear space. Worst case is n log n. Today I'm gonna use two-pointer technique. Okay, first I will explain how it works. I prepare one image. First, I will sorting nums, the not decreasing. So left side is always smaller, and the right side is always bigger. At that time, we will we put the pointer to this one is left, and then another is right. And then L is the same as low, and R is the high. So now I will calculate the three sum, and then in this time this one is minus 3, and then we needed to increase this one to make 0, right? At that time, which pointer, left, right, which pointer we needed to move? Yeah, that's right, we need to move left to the right, because this is increase. When the left node is increasing, it will be the sum must be the bigger than previous. And then if you want decreasing, you just move the right pointer to left side. Then the sum must be decreasing. That is a way we can find the sum is 0. Unfortunately, even the low is to go to here. Minus 4 plus 1 plus 2 is negative 1. So if we include the minus 4, we cannot find any valid triplet. Did it make sense? Okay. So now we made two pointer. Low is the left, same as left. High is the same as right. So left move the left. Unfortunately, we cannot find it. Then increase high, and then let's try to find it again. Unfortunately, now is the minus 1, minus 2 is the 0. So we took this one, and then we checked another, and then fortunately this one also the triplet we looking for. So put this one, and then the pointer cannot move anymore, so increase I. In this case, okay, let's see carefully. If with the iteration this one, maybe left here, right here, also we able to get the triplet. But this one is the same as previous one. Previous one is this one, right? So it will be duplicated. The reason is I value is the same as before. But how we can solve this edge case? Yes, that's right. So if this I is the same as I minus 1, we just skip. Did it make sense? So at this time it just skip, because the I and I minus 1 is the same. So move to next, and then do it again, cannot find, and then finish it. Okay, this is my approach. So now I will implement code. First, okay, let's get rid of one edge case. If length nums is smaller than 3, I will return empty, because we need to find the triplet. But less than 3 is that we cannot make the triplet from there. Next, I will make the output to return, and then I will sort nums sort, and then I will creation for I in range length nums, and then minus what? Yeah, that's right, minus 2. The reason why we deduct minus 2 means I is the leftmost pointer, so at least it needed two pointer right side to make the triplet. Did it make sense? So that is the reason why I deduct minus 2. And now I will check this one, the prevent the duplicate. So that is if nums I minus 1 is same as nums I will continue. Does it make sense? And then let's get rid of edge case. If this one is 0, nums minus 1 is the not we looking for. So we need, if we prevent this one, if I is not 0, and then we can solve this question. Let's make the 2 pointer left and right. Left is I plus 1, right side of I, and then right is the end of node, length nums minus 1, and then right, left, right, and then let's calculate the sum. Sum is nums I plus nums left plus nums right, and then fortunately sum is 0. I will put output append as array nums I, comma nums left, comma nums right. Did it make sense? And then okay, we needed to solve one more edge case. Nums is this one. Okay, let's say nums is there are 1, 1, 1, 1, 1, 2, 2. This is the nums, and then now we are here. So now the sum is same to 1, and then in this time, if we move the left right here, then we also get the triplet, but this one is the same as previous one because left value is the same. So how we can solve this? Right. So if we this one and then right is same as this one, we move to where? To here. Did it make sense? So To do it, I will use iteration. I will use while. Okay, left going to right, so I will compare nums left equal nums left plus 1, and then I will increase. Wait a minute. This nums, then close this one, right? That is on left plus 1, and then we needed to get it over edge case. In this time left must be not smaller than length nums minus 1 2, right? Because the right index, left index, so maximum over left index is length nums minus 2 minus 2 and minus 1, right? If this one is the cannot. And then do right also. Right is not I plus 1 and nums right minus 1, so nums right, because right is moved to left. One, and then after finish it, increase left plus 1, and then right minus 1, because we next start is here. And else if sum is smaller than 0, which one we need to increase? Yeah, left side, because left side the moving direction is right, and then this is ascending order, so if we increase right left, and that means sum is also increased. So left plus 1 else right minus 1, and then I will return out. Okay, looks good. Okay, awesome. Okay, time complexity is this is n log n, and then this is linear, and then inside this one also linear, so time complexity is n square, and then space complexity is we use output, so space complexity is linear space. And then worst case, if this one is a lot, and then n log n. Thank you.